Hello, today we're going to go through the results obtained for Physics 2211 Lab 4 on oscillations. So, to start off, the objective of this experiment is to examine the motion of a spring mass system through a video analysis in which the mass swings in an arc while oscillating on the spring. So the softwares used to analyze this video were Tracker and GlowScript to create our computational model. The fundamental principles for this experiment were Newton's second law of motion, which we always start with, which we can know as the difference in momentum equals the force times the difference in time. We also take into account the different forces that are acting on the system, which in this case are the spring force and the force due to gravity. We know that the spring force is equal to the negative of the spring's constant times the difference between the length minus the relaxed length of the spring multiplied by its direction. And the force due to gravity, which we can also sometimes call weight, is equal to the mass times the gravity, which is 9.8 meters per second squared. And the total force, which we know as net force, is equal to the sum of the force spring and the force of gravity. And another thing that we have to take into account is energy, which we know it's equal to the work done by the surroundings plus the heat transfer between the system and the surroundings. In this case, because our system includes all of our environment, which is the spring, ball, and earth, the energy is equal to 0, and we can neglect heat. The types of energy, which are the kinetic energy, spring potential energy, and gravitational potential energy, are all added up together to get our total energy. And as you can see, kinetic energy has to do with motion. Spring potential energy is not constant, so that's where we have to take it into account. And the gravitational potential energy, which depends on our position in y. Now, going through the observations, here we can see the values obtained through Tracker, which were the initial position, the initial velocity, which we can conclude as 0 because the object was at rest. We also have the mass of the object, which is equal to 0.402 kilograms. The oscillation, which is calculated by taking the time of 3 oscillations divided by 3, which was equal to 1.614 seconds. And we have the spring's constant, which was equal to 6.09 newtons per meter, and the relaxed length to 0.0533 meters. To get those two last values, we had to do another procedure in order to get it and put it into our computational model. So in order to get the spring's constant and the relaxed length, we took T oscillation, which we know is equal to 2 times pi times the square root of mass divided by the constant. In this case, because we have all of the other values, we isolated the spring's constant, and plugging in the values that we already had, we obtained the spring's constant as 6.092 newtons per meter. Also, the relaxed length is equal to setting our force due to gravity and our force due to the spring equal to each other, and isolating the relaxed length, which is what we want, we obtained a value of 0.0533 meters. Now, going into our GlowScript code, we can see the portions of the code that we edited based on values that we obtained from Tracker. So as you can see, we have the ball mass, which we updated. We also have the ball's initial conditions, which equals to the position and the velocity. We also have delta t, which has to be a very small number so that we can see all of the oscillations in the graph, and the values that we had to change based on the results that we obtained from the observations in Tracker. Also, these 4 lines were updated as are all the values that we need in order to obtain the energies. Now, here we can go into our while loop, which stops once it gets to 9.497 seconds. And as you can go line through line, you can see the lines of codes that were updated in order to obtain the desired value and computational model. As you can see, it is important that when we're calculating the energy, we're calculating the difference in each of the steps will be recalculated based on the current position that we have. So here we can see the values and the models obtained from the results. We have on your left the model due to the energy, and as you can see, the orange line is the one that calculates the total energy. And to your right, you have the comparison between the computational model and the experiment, which are very close to each other. Still, there's a little difference, and that's because in our experiment, we didn't take into account our drag force. To finish up, we can see that our graph satisfies the energy principle because our total energy, which is the orange line, is equal to zero, which is what we expected once we added all of the energies. And we also calculated the oscillations in x and y with our graph in tracker, and we obtained that x equals to 1.614 seconds and y to 1.487 seconds. And these were done for the time in 3 oscillations. I hope this was helpful and you learned a little bit about spring constant and energy.